Hello, this is Dr. Oz. Today I would like to talk about scheduling problem. So let's create a new Excel file here for our scheduling problem. All right. So in scheduling problem, we have different tasks or jobs, and we have project managers or machinery that we would like to combine them, assign them to one another in a way that we can minimize the total cost. So let's build our model. Before starting our model, I would like to enter the given information. This part will take a little bit time because I have 7 by 749 numbers here. All right. So let's start entering the information here. I have jobs here, and it's job A, job B, job C, job D, E, F, and G. I have 7 jobs. All right. And I have 7 different project managers. So let's name our project managers. Again, it's a very generic common problem that you can use in your company. I have Steve, Kyle, Brianna, Brian, Lisa, yeah, and Tim. These are my 7 hardworking, smart managers. Right? So I would like to enter now the cost information. So if I want Steve to do the job A, I have to pay $7,900. If I want Steve to do job B, I have to pay $6,200 and $8,300, $9,600, $6,500. If I want Steve to do job F, I need to pay $9,700 and $8,600. If I want Kyle to do job A, I need to pay $7,500. For job B, $8,000. For job C, $7,600. Job D, I need to pay $8,100. Job E, I need to pay $6,200. Job F, I need to pay $9,900. Job G, I need to pay $7,000, sorry. And as you see, every manager has different skill set. So some managers are doing certain jobs cheaper. Some managers will cost me more. For example, to be able to do job G, $8,600 versus $7,000, but I cannot make Kyle work all the job for me, right? So that's why I'm trying to assign these project managers to these jobs, right? So merge center here. Align this and my project managers. Beautiful. So Brianna, she will charge me $5,700 for job A. C 7,300, 9,300, 7,900, 7,900, 8,900, and 6,200. All right. Brian, to do job A, 6,500, 5,900, 5,400, 7,700, 7,100, 7,600, and 7,100. If I want Lisa to do this job A, I need to pay 7,900. For B, 7,500. For C, 6,500. For D, 8,300. And 8,800. 7,600. 7,900. Again, you may have company that has hundreds of managers, hundreds of jobs. This is a very general example, 7 by 7. Yeah, she would charge me 5,500, 6,500, 8,700, 5,900, 7,000, 8,700, 5,000, and team would charge me 6,900, 6,600, 5,000, 9,700, 7,900, 5,000, and 5,600. All right, so these are my costs, and let's build our model here. Build our beautiful model right here. All right, so I will copy paste this matrix. Again, these are my costs. Maybe I can put it here, and I will copy these. I will use this table and put it right here. Okay, so I will delete these numbers. So first thing I ask myself, what's my objective in this model? So as you can see, these are all costs. So I'm trying to minimize the cost. So I will calculate the cost value right here. I will put a green cell. All right. And second question is, what are my decision variables? In this case, 7 by 7, 14, I have 49 decision variables. I will color them yellow. And now I need to introduce my constraints. To make it easier, I will just put this object a little down. So I have constraint left-hand side versus right-hand side values. Again, as you know, left-hand side should be calculated. In this case, I will sum the column, which means that Steve can be only assigned to exactly one job. Okay, I cannot assign Steve more than one job. And same thing for all these other other 6 managers. I will just copy this formula. I don't want this one to be 1. I'll Control C, Control V. All right, so these are sum equals to 1. Perfect. So these are my constraints associated with my project manager. So I will color them something reddish. And now I will do the same thing here, left-hand side versus right-hand side values. Again, it depends on the constraint, but this is context. This is, I have 7 managers and I have exactly 7 jobs, and one manager can only take care of one job, and one job can only be taken care of by one manager. So I will do the similar trick here. This time row sum should be equal to 1, okay? Because I can only assign job A to one manager. That's the assumption in this model. Okay. This is not a dollar, this is number. Perfect. So as you see, these yellow cells are my decision variables, and green cell is my objective, and the red cells are my constraints. Now I can calculate my objective, which is minimize cost. So I can use some product trick. My decision variables are here, comma, their corresponding costs are right here. Okay, currently I have $0 cost, but it will increase based on the assignment. So now I'm ready to run my model. So if you don't have Excel Solver, you can go to File, Options, Add-ins, Analysis Tool Pack, go, make sure the Solver is checked, click OK. Now under Data tab, you should have Solver. My objective is the green cell. This is the minimization problem. My variables are these yellow cells. And I can add my constraints. I have two sets of constraints. One regarding to my project managers. I want to make sure that each project manager is only assigned to one job. Add. My second set of constraints are my job assignments should be, each job should be only assigned to one manager. Click OK. Again, I have two sets of constraints. Each of them has 7 constraints, so I have 14 constraints here. I want to make sure that my yellow cells are positive, and I would like to do this model, and this is linear programming as well. I click solve. All right. So constraints are optimal conditions are satisfied. That means that Excel could find the best solution. Of course, these are not dollars; these are numbers. If it's 1, means I assign it. If not, I don't assign it. As you see, these are my values, right? These are my assignments right here. So as you see, the lowest cost here that I can obtain is $41,800. $800, yes. And I assign Steve to B, Kyle to job E, Brianna to job A, Brian to job C, Lisa to job D, Ye to job G, and Tim to job F. And this would give me the best combination. As you see, every single person is assigned. Every project is assigned to only one person. If you want to make sure that your values are either 0 and 1, which is in this case, but we could have some partial numbers. In this case, we don't. You can also add another constraint, data, solar. You could add another constraint here by click add and tell Excel that these values, decision variables, are binary, means either 0 or 1. Click OK, and if I solve the problem again, I got exact same solution because anyway they were binary, but that would eliminate the possibility of getting partial numbers. That's it for scheduling problem, and enjoy supply chain management.